Hello, chemistry students. As promised, here is the instructional video for double replacement reactions. So we've talked about synthesis reactions, we've talked about decomposition reactions, we've talked about single replacement reactions, and the activity series. And this video is to discuss and teach you about double replacement reactions. And you'll notice things look different than a single replacement reaction already, because we have a compound right here and it's reacting with another compound here. No one is single here. So one analogy I like to use is that we have a couple of dance partners. Here's two people that are dance partners. Here's two people that are dance partners. And at some point in the dance, they switch partners. You'll notice that the sodium is going to switch places with, this is cadmium. And so now on this side, we have the cadmium has now combined with the sulfur, and the sodium has combined with the nitrate ion. So again, we do have to know those charges. So pull out your ion sheet once again. So sodium, if I look that up, is a +1. Sulfur is a -2 or 2-, it doesn't matter which way you write that. Cadmium is actually not on your sheet, so you have to use kind of your inferences here. Nitrate is a -1, and I know that since I have two of these nitrate, that the cadmium must be a +2 charge. And then when I combine them over here, yes, I can see the +2 cadmium combines with the -2 sulfur to write in a 1-to-1 ratio. And the same thing with the +1 sodium and the -1 nitrate. So let's go through these two really quickly. So this one, you'll notice, so sodium is a metal. This is an acid, so it has, instead of a metal, it has hydrogen as that positive ion. So I'm just going to switch these two. At this point, yeah, we're just going to assume that reactions occur. So sodium, we said sodium is a +1. Cyanide, if I look that up on my handy dandy sheets, the cyanide ion is a -1. And I would already know that because these clearly combine in a 1-to-1 ratio. Hydrogen is a +1. And since it took two of these to cancel this out, this must be a -2. But if you want to look them up on your sheet, that's totally fine. So what are they going to be after this reaction occurs? So the sodium is going to switch places with the hydrogen. And it wouldn't matter if you switched the two negative ions, it doesn't matter, just so you pick, either both anions or both cations and switch them, right? So this is my sodium, which is a +1, sorry, writing with my mouse, combining with the sulfate ion, which is a -2. So I know I'm going to need two of these, Na2, SO4. So that's one of my products. The other one is going to be the hydrogen is going to combine with the cyanide. Since this is a +1, this is a -1, it's just they're going to combine in a 1-to-1 ratio, HCN, and that is it. So I would encourage you to pause this video right here and see if you can do this one, and then let's check our work. All right, so I'm going to go ahead and do this one really quickly with you. So I labeled my calcium as a +2, hydroxide is a -1, hydrogen is a +1, and chloride or chlorine is a -1. So calcium is going to trade places with the hydrogen on here. So this one gets, okay, This one I think is kind of interesting. So calcium is going to combine with chloride. Let's start with that one. Calcium is a +2. Chloride is a -1, so it's going to actually take 2 of those chloride ions. Remember how we do that? That crossover method from chapter 7. Here's the other interesting thing with this one. So this hydrogen is going to combine with the OH in a 1-to-1 ratio. So if I write it this way, and I'm not gonna hammer you for that one, but HOH really is H2O, right? If we reorganize those and write it in that way. So that is double replacement reaction. Okay, so let's work through a couple more examples. And right now, we're not going to worry about whether a reaction really would happen or not. We'll cover that in the next video, but I want you to have a good background of just how to switch these ions, these positive ions around, and to make sure that, right? So first time, and it wouldn't matter, like I said, if you decided to switch the negative ions around, it doesn't matter, because ultimately we're just doing a switcheroo where, you know, we're either switching both positive ions or both negative ions. The end result would be exactly the same. So copper chloride combining with sodium chlorate, that's what this one is. And remember that there's a couple different forms of copper. So how do I know whether this is copper ion with a +1 charge or copper ion with a +2 charge? Because it doesn't tell me that necessarily, but really it does. If we look at, so this is, we know that the chloride ion, let me take a different color here, the chloride ion is a -1 charge, okay? And looking, so I can kind of do the reverse for those of you. There are some of you that I know, this is just going to be like, wow, we haven't talked about this for a long time, and now all of a sudden we have to remember those charges again and how to combine those ions. This 2 down here means that this is copper with a +2, okay? Sodium is a +1. You can look that up on your ion chart. And so chlorate, ClO3, must be a -1. So looking at our, move myself out of the way, looking at our products then, we are just, again, we're just doing a little switcheroo here, switching my copper with my sodium. So now the copper is going to combine with the chlorate. And why did I have to know those charges? Because I have to know what ratio they combine in. So copper's a +2, chlorate is a -1. So I only need 1 copper, because remember I can use that crossover method. And then chlorate, ClO, so apologize for the penmanship here, ClO3. But since my copper was a +2 and this is a -1, I need 2 of these. Well, that looks like 32. We don't want that. So I'm going to very sloppily, sorry, put parentheses around that. So that this is so that we know we have 2 of this whole unit, right? Let's just for fun, maybe let's try to go through the balancing part of this, because we haven't reviewed that for a while, and it is important. So let's just see if we can't balance this one really quickly. Actually, I have to finish my problem here. I have to write my other sodium chloride, NaCl. All right. So do I have sodium chloride, copper, chlorine, oxygen? I think we have everything. All right, so I'm going to start by just writing down what I have for each one of these. So I have 1 copper. I have 2 chlorine, but I have another one here, so really I have 3. The sodium I have 1, and oxygen I have 3. On this side I have 1 copper. Chlorine I have 1 plus 2, so I have 3. Sodium I have 1. This is going to be super easy. Oxygen I have 3 times 2, which is 6. All right, so right now the only thing that's not balanced is the oxygen, right? So what I want to do, I need to balance this oxygen. So I'm going to put a 2 in front of this, which makes, get rid of that, makes my oxygen on this side 6, but it also changes my sodium to a 2. So now the sodium's not balanced, so I need to go over here and put a 2 in front of my sodium, which gives me 2 sodium, but it also changes my chlorine from, I have 2 here, and now I have 2 here, so I really have, I'm just going to get rid of that, I really have 4 chlorine now. So now my chlorine's not balanced. What am I going to do? Oh, wait a minute. Actually, yes, it is. I forgot to change this when I put that 2 in front. So my chlorine, I have 2 chlorine here and 2 chlorine here, so I actually have 4. All right, so just double checking. I have 1 copper. I have 2 plus 2 chlorine, so 4, 2 sodium, and 2 times 3 or 6 oxygen. And on this side, 1 copper, 4 chlorine because I have 2 here, and then I put a 2 in front of this, which we multiply everything. So this would be 2 sodium in this one and 2 chlorine. So the 2 chlorine from here, 2 chlorine from here gives me 4. 2 sodium. Remember, the coefficient in front of means you multiply. It's like distributive property. You multiply it by everything that goes after it. And I can only balance these by putting numbers in front of. I do think we need to have some more practice with that. I know that's not the highlight of this, but I still think it's really important. All right, and all the more reason why these formulas, when you predict these products, it has to be correct. Otherwise, it'll never balance, and you'll find that. So. All right, let's do another example. Okay, so please pause this right here and see if you can finish this before we do it together in class. All right, so let's dissect this a little bit. I'm going to identify remember, positive ions are always the first ion in a formula, and make sure that you write it that way, just a little reminder. Again, that's from a couple chapters ago, so we want to make sure we remember that. So my barium is going to trade places with the aluminum. I'm going to pause this and look up my charges because I don't want to run out of time here. Actually, this is pretty simple. I mean, please look them up if you need to. I know that hydroxide is a -1, and since there's a 2 down here, I know that this is going to be a +2. Aluminum is a +3, combining with this phosphate ion, which is a -3. Obviously, they combined in a 1-to-1 ratio, so whoops, pretty simple and straightforward. All right, so barium is going to combine with phosphate, right, because we're going to switch these around. I need to be aware of my charges. The phosphate was a -3, so I have to put a 3 here. The barium was a +2, so I'm going to put a 2 here. And of course, I need parentheses around that. I'm going to pick a different color. And then the final product, AlOH3. Perfect.